Okay, so today's carry on of last time's talk. It's called open science. So last time we did research culture. One of the major part of research culture is open science. So I thought I'll just take 15 minutes on open science. So this talk is mostly taken from this article in Journal of Clinical Epi, which was published recently in 2025. I'll explain it. It's based on a concept by UNESCO, United Nations. It's open science knowledge, open science infrastructure, open engagement of societal actors, and open dialogue with other knowledge systems. So these are the basic four fundamental principles of open science by UNESCO. So it's a sort of not new, but it's been there for a while. For 2021, UNESCO said research should be inclusive. That means we can't have only like Andrew said, rich people, poor people. Research should be inclusive. Research should not be only doctors. Various movements, various research practices. In India, Ayush, not only allopathic, not only rural or urban, tribal. It should be an inclusive practice. Multilingual. So research should not be English based. I think Andrew's talk prior to this, he said that unless you spoke English in a European country, you were not included. That will exclude a large number of people, and the results may be totally skewed if it included non-English speaking. The result should be available to everybody. So it's very often in India when we search for a journal, we find you have to pay 50 euros or $100 for an article, and so it's automatically inaccessible unless we do some backhand technique. Accessible means it should be freely available, accessible. Reusable means I do research and then I keep the data with me. Nobody else has access to my data. So these are the major principles. So available, accessible, and reusable. We should be happy to collaborate and share. That should be a change in our attitude. Most researchers are like, it's I, me, and myself. I've got my data, I won't show you. And your colleague will say, I have my data and I won't show you. So, what are we collaborating? Scientific knowledge creation, evaluation, and communication. Everything should be shared. Societal actors are people in the society, maybe doctors, maybe engineers, maybe social workers, health economists, social scientists. We have to involve everybody in research, not just the doctor community. So, societal actors are all people. So, what is this movement? So, the conduct and report of research should be done transparent. That's a change. So, currently now you can't make out how somebody did a research. Was there a protocol, Andrew, for your study? Did they have a research protocol published online? So they could have given a protocol. This is how we plan this research and what is done. So this is part of United Nations Sustainable Development Goals. So the scientific knowledge, which I told you should be accessible to be all, the way it is produced, the scientific knowledge is accessed and produced. There are three important things. Inclusive, that means include everybody in your research as much as possible. Don't exclude people. Equitable, meaning the rich should not be able to access it more than poor. People in urban areas access the research better than rural areas. Sustainable is like you can't have some data collection model which will run out of money very quickly and say that we can't sustain this particular data collection and sharing. So these are the main principles of this best practices. So since we are in clinical epi, the first thing is study registration. Clinical Trial Registry of India says that even all PG thesis, whether it is RCT, case control, cohort, qualitative, diagnostic, can be registered. And in many countries, you don't have to register only RCT. So once you register any study, then people can know that this is what you plan to do, this is what you finally do. So we should also encourage all our faculty and PDs to register all our topics, not just RCTs. Second, open data, code, and material. You should be willing to share your data with everybody. Now, the statisticians are there. You have data and you have the tables in your paper. How do the data become tables? You wrote some scientific commands. That is called code. So you should not only share your data, you should share the code so that other people can reproduce your results. Thirdly, you should say what software you use to analyze your own data. And since your protocol is available, people know why the data was collected, how it was collected. Then they can understand your thought process in the whole study. That's open data code and materials. Reporting guidelines. Now, I'm going to use CAS checklists, but there are stroke checklists for reporting. CASP is for appraising somebody else's literature. So we must encourage everyone to use the stroke checklist for observational studies. Preprint is, I will talk about this again in a little while. Preprint is a journal where you can publish anything without peer review, but it's up there and it's shareable to everybody. Lastly, don't charge money to people to read your article. So the reader should be able to read your article. That is open access. Here's an example. Every 6 months we hear of Ebola outbreak in Africa. So now the West African countries widely share genomic data, epidemiology data, and clinical data with the whole world. So they say that if we give all this to the world in a time-sensitive manner, we can develop medicines for Ebola, vaccine for Ebola. Non-pharmaceutical is like social distancing, mask, what works, what doesn't work. So the West African countries share this data with the whole world. So the samples also are sent all over the world so people can analyze and plan for themselves. However, once the data is shared, nobody says what we should do with the data. You can analyze and do whatever you want with the data. That's a big problem because once I share it, my data with, let's say, Andrew from another country, I hope that if he finds something, he will tell me, hey, this is what you should do so that I benefit from it. But the West African countries are complaining. Everybody takes our genomic data, our epidemiology data, but they're not telling us how to change our practices or behavior. So even if you share data, there should be some way of that person benefiting and telling you also, I think this is what you should do. That's an important part of this. So what are you sharing? FP data. FP data is what you collected: height, weight, age, whatever, comorbidities, genomic data, clinical data, and samples. So there should be some system of sharing this. There should be a framework for, like, okay, if I share it, what are the rules? Can you share it with everybody else? What can you do with the data? What you can't do with the data? Unless we have this before a pandemic, it's too late to start this process during pandemic. So we have this good behavior during pandemic, the good behavior will continue. So we should assume that suddenly when a pandemic starts, we'll start sharing data and knowledge, and all of us will behave properly. So prompt knowledge production and research. So in COVID, we all had that. People were sharing the viral genome. So everybody in the world could make vaccine because people shared the viral genome. So prompt knowledge and dissemination. So you must enable that everybody in the world can access that information. You can say that people pay me and I'll give you. And poorer countries can't access your data. So getting started. So how do you do this open science business? You may not have heard this word before. So the first time you share something, you may not know how to share it. That may be why you're not sharing the data. So you need some skills. Most of us are learning on the job. I'm also learning now about open science. I'll show you that open science website. Unless you have some training in sharing data, you also won't know how to share. So these are the things. So this open science is a big term. All this put together is open science. So we will have some training in this umbrella work. So what are the little threats to this? Last week we learned some of this. So the first one is design of the study. If your study is poorly designed, the sample size is low, study power is low. If you don't collect the data properly, good study design but poor quality data. If you don't have an analysis plan before, like I was asking Andrew, do you have a protocol? Protocol, we said this is how we analyze the data. But if we can keep on analyzing, that's called p-hacking till we find some p-value. Interpreting results, we can make the non-significant results sound significant by doing some spin-off. Publication bias, we only publish the results which are so significant. We don't tell the world all the results which are non-significant. So that's a publication bias. Once we do the whole study, we find some p-value which was significant. And then we say that was our hypothesis. That might not have been the hypothesis at all. And we finally conclude whichever p-value is significant, we rework the story as if that's the hypothesis. That is called harking. So harking is hypothesizing after the results are known. The last week also I mentioned that. So be careful of that. No replication means if I don't tell you clearly how I did my study, you cannot. So unless I know how Andrew's cohort was done, how they collected the data, how they analyzed, I cannot replicate the study in India. But the methods seem to be quite good in that article, so if you want, we can replicate them. In fact, the US study was replicated in Europe. Analytical flexibility means I can't decide halfway through, instead of doing this method of analysis, I'll try that. People, it's a fancy word for keeping on fishing till you get a p value. That's p hacking, publication. Lack of sharing is an important thing. So all of us must get used to this, sharing our data. So let's look at this one. Study registration. So we only are used to study registration in India, which is CTR, Clinical Trial Registry of India. If you share your protocol, research questions and outcomes, study design, analysis, your data collection methods, the statistical analysis plan or SAP before, then other people will benefit. So then you can separate confirmatory statistics with what? What I planned is what I did. I confirm what I planned. Exploratory statistics is what? After seeing the data, I got some ideas and I'm trying some new statistical techniques. We must limit exploratory analysis. Much of it should be what we planned in the beginning. That's called confirmatory data analysis. I've talked about these parking, cherry picking, and other things. So there are, how do we do this study registration? There is one, all of you can try. I don't know where to register my study. RCT only I can do. Open Science Foundation is a website where you can register your study. Anybody just go Open Science Foundation, get a username and password, upload your protocol, you'll get a registration number. Another one is called PROSPERO, International Prospective Register of Systematic Reviews. If you're doing a systematic review. Open Science Foundation is free and easy to use. So this is the website, it's called OSF. And if you just Google OSF on YouTube, you'll get a 15-minute video. What is OSF? How to use it. So think about all of you, all the studies you do, put it on OSF. So it has got many things. You register, you can add your protocol, you can upload your data, your codes, the software you use. So it's a fantastic site to do this work. Also, the advantage of putting in OSF is if you share a link, like a web link, anybody can just go to the web link and access all your data. So it's completely shareable. It's also controllable, meaning I may decide that I'll share the protocol, my data, my codes, everything with Dr. Vignesh. So I'll give him complete access, but I may give somebody else only limited access. Somebody else can see the data and the codes, but may not see something. So I can control who sees what. So it's a fantastic opportunity. The second one is this: if you are doing a systematic review, you can register your protocol free of charge in this website called Prospero. So this is a nice place for people who are doing, and it's maintained by the University of York. So it's a good place to register your protocols. The next one, this open data code material I told you about, which you can upload in Open Science Foundation. It should be freely accessible to anyone. So are there some principles for sharing data? So I can't share my data and you misuse it, publish in your name. So what are those principles? One is called FAIR. FAIR stands for findable. That is, if I keep it somewhere hidden in some Swiss bag, nobody will know I get the data. Accessible is, I may say it's there, but I may not give you access to it. Interoperable means I kept it in one data format, which your computer, even if you download it, you can't open it because it does not know how to read that particular data format. And reusable means if I don't tell you, like all the PGs we tell, data dictionary. What does bad word? SOB mean? Shortness of breath. But in some other countries it's a bad word. So suddenly if I have my data has lot of acronyms and I don't tell the reader or the next analyst what does that data mean, then even if he has access, he can't analyze anything because he doesn't know. So we must add the context, the protocol, data dictionary, then only it becomes reusable. There's another one called CARE, collective benefit, authority to control, responsibility and ethics principle. I'll talk about this CARE principle. So when we share data, we must make sure that it follows these two things, FAIR principle and CARE principle. Now, in the resources, what I told is Dataverse. So if you want to share your data with other people, one I told you is Open Science Foundation. The second place all of you can share your data is called Dataverse. So just go to this website, Dataverse. create a username and password. You can upload your data and your protocol and everything there. Even if your laptop or computer crashes, it is kept safe there. So Dataverse is a good repository for keeping your data. The second one I told you is the FAIR principles. Anybody knows what is metadata? Anybody knows? What is meta and photo?
What it captures a lot of information about where the photo was captured,
It's not the photo itself, it's where the photo was taken, what camera, what light, what settings. So it's data about data. So this is an important thing which all of us must learn. What is metadata? So this FAIR principles talks a lot about metadata. So there are 5 types of metadata. One is descriptive metadata. That means the data is owned by Andrew and the data was collected on this date and he's the owner of the data. Structural metadata is like the data is shared or kept on this website and part of the data is here, other part of the data is here. This is how the data was joined, structural metadata. Administrative data is the person who owns the data, the rights to the data, those kind of things. Technical metadata is how many patients I have, what are the variables I'm collecting, what are the missing number of data, the range of data, the coding of the data, that is structural. Preservation metadata is where will it be stored, who can access it, how can you get permission to reuse it, those things. So these are all data, it's not the data itself, data about data. It's called metadata. So just to introduce a new term. So this FAIR principles talks about. Okay. The next one is called care principle. So these are called indigenous people. I think it's a little bad word. The people living in a country originally before somebody else came to the country and made them the displaced minority. They are now called indigenous people. So distinct social and cultural groups. They have some ancestral ties to the land. They are the original forebearers of the land where they live and occupy. Or mostly they have been displaced from their original place and are now living in small areas and they are labeled as indigenous people. So for indigenous people, there is a care principles. So for example, there was once a trial of vaccine for cervical cancer. So those cervical cancer vaccine was done on tribal girls. Some tribal girls died during the vaccine. Then they said the vaccine was a side effect. And then they said you didn't get consent. And the tribal girls will be the last people to access the vaccine. So you have unnecessarily just taken somebody who won't understand consent and done research. It was a bit of a, I don't know if it was true or fake. It did happen, but there were a lot of money issues about why are you doing research on the poorest people who won't benefit from the research finding. So now there is this care principle. One is called GIDA, Global Indigenous Data Alliance. So this care principle is on indigenous data governance. So there are principles for doing data on, sharing research on, and sharing data of indigenous people. So this is another thing to just keep in mind if you are doing research on indigenous people. The next one is reporting guidelines. So any structured guide for authors transparently report research following an explicit checklist. So Andrew did the checklist of CAP, was a checklist for critically appraising an observational study, which was a cohort study. But if somebody, an author, wants to know how to report his own thing, there's a guideline how he should report everything. The minimum guidelines, how to appraise, synthesize, replicate. Now, there are many reporting guidelines. The most famous one of that is called Equator. It's not a reporting guideline. It's a website which collects information on reporting guidelines. So it's not it's like a repository, it's like a marketplace. So this is a website for Equator Network. So any kind of study you're planning to do, you can go to Equator Network and say, hey, how am I supposed to report it? If I know how I'm supposed to report it, then I also know how I should do it. So though it's not meant for planning research, it is very useful for research. Though it's meant for reporting, it's also very useful for planning. So this is a very nice website. Now I thought like just yesterday, Dr. Pratap Talian made me that, hey, CONSORT, which is for randomized control studies, you can see here, consort statement. The first one is randomized control studies. 2025 update of consort statement has been released in April 2025. So I looked at the statement. It's published in the BMJ, JAMA, Lancet simultaneously. So you can find the same publication in all journals. And the Sally Hopewell and group have put up this. So the previous consort statement was done in 2010. So, for example, Krupa is doing RCT, she has to follow consort checklist. So they have also put up the differences between the previous consort guidelines and the current consort. There are 3 or 4 differences. I only picked up one. Item number 4 is called data sharing in the new consort 2025. That data sharing is how, where and how the individual de-identified participant data, including data dictionary, statistical code, and any other materials can be accessed. And you must say where that is in your article. Whereas in the previous consort, this was not there. So I'm just saying open science is previously a movement and good idea, but now when it comes to the consort, people will be forced to say all this. So I'm just saying that it's not coming. It's not a big thing. Now it's coming to. The next one is publishing, open science publishing. Most of the time, when we publish an article in a journal, the author has to pay money to the journal. That's called article processing fees. Once the author pays, anybody in the world can read that article. So those journals are called what? Open access journal. It's good for society, not so good for the author. There are other journals where the reader has to pay for reading the journal. But it's good for the author because it's free to submit to that journal. Some journals have both. They make the author pay some article processing fee and the reader to pay. I mean, I'm not saying anything is good or bad or making a moral judgment. So, where open science means articles should be freely accessible to everyone. Broad dissemination of research findings, reducing disparity and research access. If I make people pay, who will suffer? People from low and middle income countries who can't afford to upload their articles to high class or what we call high quality journals because it's very expensive and they can't publish. So I'm going to talk about 3 resources that we have. The first one is this particular, it's new to me also, openaccess.nl. It's from Netherlands. So you can put your topic of interest. Reba, what was your thesis topic? So you can put scrub typhus or cytokines. And if you click this is in Dutch, I suppose. I don't know the language. Then it will tell you these are the journals in which open access, which is free for you to submit. So this is a nice way for you to find out where can I find a place where I can submit my article free of cost. So when I put a term, I simply put chlamydia and pneumonia, and then it said that sorry, there are no free journals to publish it. But anyway, at least you have some access. So this is a website which is trying to help people from lower and middle income countries to find journals which are of their topic which they can submit free. So this is openaccess.nl. So it's from University of Amsterdam. Next we move to preprints. I told you what are preprints. You can just submit anything you want to a journal. They won't ask you any questions, how you do the study, what you did. But it's there. It's like before anybody else could. I'm the first to get it out. Because main advantage is other people cannot grab your work or steal your work. I finished my work, I published it. But the problem is that prevents other people scooping your research and or saying something about it before you. But the problem is when you submit to a regular journal, there's something called peer review. 2 or 3 experts in your field will go through your article. A is a good scientific content, B is ethically done, C statistics are good, D English writing is good. Is it really worth? It's very good study, but will the readers of the journal benefit from it? Then they'll publish it. And 2 people peer reviewed or 3 or 4. That process takes 6 to 9 months. That's why people are, these articles are taking a long time. But that peer review makes sure some quality standards are there. Mistakes will be picked up. But preprint server, there is no peer review. That's a back side of preprint servers. So let's have a look at some of those. This is one of the famous ones, Vellore. During COVID, so many people publish articles in Vellore. Just put it up there. And this is a particular easy one. I'm given the website there. The other one is called MedLib. Again, a place where you can access reprint articles. The third one, ASAP Bio. This is another preprint server. Just giving you ideas that at the end of your research, you find it, I cannot publish it anywhere. I've tried many places. At least the world will have access to this. You know, some complete research, I can find it somewhere. In good place to go to a, but most people do the other way. They put it up in preprint server and then they try to put it into the regular journal. So what will happen there? It will be two places. Usually there will be a difference in the regular journal article because the peer review would have modified slightly. So you'll have to, you can't delete it from the preprint server because that is the document, it's a site. And you've got two versions of the same document. So be careful about this, having two versions of one document, which may be quite different from each other. So this is some things to just keep in mind that people copy and copy and copy. So one of the problems with open science is our data is freely available and we copy it. So plagiarism is a big problem. Many people don't think of it as copying. Hey, I'm giving homage to WHO, beautiful introduction. I'm copying and giving reference. So be a bit careful about copying. So the second problem with open access, why people don't like, in most countries in the world, including India, the promotion is based only on publication. If that is the case, then I don't want to share my data with somebody else because my promotion is already risky. And if he benefits from my data, why do I want to share it? So that's called publish or perish. So there the risk now very quickly is come to everybody in India, not engineering, medicine, agriculture, veterinary, dental, nursing. So this publish or perish culture is a little anti to open science. The third thing is you have to find somewhere to publish an article. So you'll find that I did a study on stroke, nobody is accepting it. I keep on trying hundreds of times till finally somebody accepts it. So it's such exhausting business trying to publish. I've also been there. You've done a lot of work and you want to publish somewhere. So that's also an exhausting business. So preprint servers may be a good way to get over this particular problem. Why are people moving to this cost? Why are people charging you money? Suppose you have, let's say, the Lancet. There's a print version of Lancet in our library, and there's also an online version. You don't have to go to library to read a journal anymore. So the majority of the cost of article processing, that means you get the article, you send it to somebody else, they peer review it, somebody checks the spelling, the English, typesetting, and all those are a lot of money. The second costs are other costs like editorial costs and printing costs, managing costs and margins, your profit. So journals which are print and online have this cost structure. Journals which are online only, that is subscription. Some of the costs are article processing because the same cost will be there to print and such. Now we have moved to online only. Online only means it's free for everybody. So cross medicine. They don't have to worry about giving you rights to read it or not because it's free for everyone. So there, the journal costs become very low. So there's online only and free access to everybody. Their cost for the journal is low. It's something to just keep in mind. If you are starting a journal, online only is a very low cost method of doing it. But you can see that there's a relationship between the influence of the article and publication fee. So there are only few journals which are high impact but low publication fee. So we should aim open science means very good journal, but anybody can publish and it's free. But if it's free, then who's going to pay the journal editor and the staff? That's also another question. So that's not an easy answer. We can't judge anybody, but this is something to keep in mind. Some of the other things can be time consuming. So you're going to share your data, upload your data, give all this. It requires extra effort. So data sharing, it takes some time, but I guarantee you, if you go to the OSF website, see that OSF 101 YouTube video. Within 15 minutes, you'll know how to share your data. It is that simple. It's just like any other website. So the other problem is our current rewards. So who's a famous researcher? He's got 6 publications in the world's top journal in his area. What is the top journal? Impact factor. Impact factor journal is how often somebody cites that journal. So you can see it's a game which can be played. So if you don't have high impact, you don't get promotion, you don't get recognition. So you're always trying to catch high impact. That increases the impact of the journal. So this is some things to keep in mind. So this incentivizes quantity. If I have multiple publications in high impact journal, I become very famous. So instead of quality, transparency, and openness, people are asking, why should I share my data with somebody else? Then give them one leg up over me. It took me a lot of effort. So this kind of unhealthy competition comes through, which we should avoid. So if we reward researchers for sharing data, promotion is based on collaboration. Promotion is based on how you've shared your data, given your code, your data, then that will change the whole research culture. But that's something which we need to work on not only here, but everywhere else. That it's not only the impact factor, how many collaborators did you have, did you share your data, that also should become important. Preprint. Okay, I've already spoken about this, so I won't belabor this point. So we must encourage all our researchers to do preprint. Some people have the false notion that if I put in a preprint, I can publish in another journal because preprint is already one journal. That's not true. It's just a repository of your work. High cost is a problem. Suppose I have data on alcohol use, domestic violence, sexual behavior. It may not be wise idea to share that data. So sometimes you must be sensitive about what data you are particularly sharing. Suppose I do this Andrew's cohort study. Would they have taken consent from the patients initially that I'm going to share my data with somebody else later on? So we don't know when the cohort was assembled. Did they say, okay, you can publish my data in the US? No, no, I'm going to now share your data with somebody in Europe. Then we'll combine all the data together. So the issue of consent of these large scale projects becomes an issue. You take the consent after the data is collected for some other purpose. You say that consent should be waived. So these are not easy things to consider. If you're sharing data, what about the consent? You tell the original person, hey, I took it for this project. Now I'm going to share your data widely all over the world. So that's an issue about consent. So what do you share? Do you think, Krupal, that one day you can share the name and hospital number of your patient? That's called de-identified data. You take away the name, hospital number, or identifiers. But given people's technical abilities, you share your data with somebody. Would it be possible for somebody to re-identify those people who they are? So this is the worry always when you say I'm sharing de-identified data. Because of your foolishness, not foolishness, because you slipped up, accidentally the name, age, gender was there, or the age, gender, and location. You are a 30-year-old male living in CMC Vellore who's got blue top and gray hair. Then it's easy to find out because you didn't give the name, but somebody can re-identify you. I'm making fun, but re-identify, especially if it's some privileged information, sensitive information becomes an issue. So this is one barrier to open science. My second last slide, in France, they are big on open science. So for example, in 2013, only about 40% of their publications were open science. But if you go now to 2022, nearly 65% of all data in France is open science. So it's also a culture, it's a movement. Like everybody in India should move towards this kind of a culture. That's the hope at the end of this presentation. Suppose one of you is interested in open science, you want to read some more about it. There is this website called Open Science, and this is the UNESCO website. You can read it, and there are some toolkit how to do this. If I want to do it, how do I go about? There's a UNESCO toolkit. The last one, the future. There is a conference which is called International Open Science Conference. I'm not preparing for it. I'm not saying you go for it, but there are places you can go and see what are people talking about, how are they doing. You can keep yourself abreast of it. Yeah, this is adding on last week's talk on research culture. Open science is one part of research culture. Some people may say it's a huge overlap. It's okay. It's a general idea which I just wanted to over. Okay. Any questions?